Hello friends, this is Durga from ITversity. As you guys know, this is the backup for my live audience who are joining through WebEx. So in case for those who are on YouTube, if I could not answer in time, bear with us. We will try to respond using different platforms. That being said, if you like this video at any point in time, please click on the like button. That means a lot for us. And also you can provide feedback in the comment section once the video is completely streamed. And let us get started. Those who are on WebEx, please confirm you can see me and you can see my screen as well as you can hear me, so that I can get started. Okay, thank you. So yesterday I stopped at analytical functions, so we'll continue from there. Okay, so I am opening the course material just in case if I have to refer that. And and this is the query we have written yesterday. I am running it again. I'm connecting to the lab. I'm launching Spark Shell. So yesterday you have seen that I have been testing this query in Hive. Now I am running in Spark Shell to make sure that it runs in Spark Shell, and then we can take it from there. Sure, Kishore, I will share it for your reference. So this is the query. I think I have shared yesterday also. Anyway, so here, if I run this query, I have to put it in the codes and all. So let me do that. There should be a shortcut for this. Okay. Now I can say SQL context.sql. Before that, I just want to set the database to wlab_bg, and also I would like to set configuration parameter arc.sql.shuffle artisans to 2. If you are using Spark SQL, you just have to say like this: set spark.sql.shuffle.partitions equal to 2. The same way we typically do in Hive. Okay. And then I would like to run this query. Dot show will give the first 20 records out of the query. So you can see it here. We get the order ID, we get the date, we get the product name, product category ID, product price, product item subtotal for that order. And then for the combination of product name and order date, we got the revenue. Okay, now if you want to get the strike rate of each of this order out of the for that product, I can just divide this one with this one, and I will get the percentage of revenue generated by this order within that date and within that product. Okay, it is approximately 50%. So like that, we can do whatever we want. So these functions, uh, let me show you here. This notation of using over and partition by the way you want is called as analytical functions or windowing functions. Okay, the major difference between windowing and analytic functions are if you try to get the rank of the data, or if you try to get aggregations, it is called as analytical functions. Windowing functions are if you want to consider that as a window, and if you want to do some different type of analytics. For example, if you have multiple records within, for example, let's say you want to compute something in time series. If you take a HR database, if you want to see how many days it is a new employee is leaving or being hired. Whenever a new employee hired, if I want to compute the difference between today's date when the new employee hired and the last employee hired and get some insights out of it. Those are called as lead and lag functions, which we typically use using same over partition approach. Those are called as windowing functions. I will show you from the official documentation, and I will explain. But the skeleton of using windowing functions is almost similar for both windowing and analytical functions. Okay, so let me show you the official documentation, then you will understand. So here I'm going to Hive user guide. Yeah, queries. Not this one. Somewhere we should have, yeah, windowing over and analytics. Okay, so here you can see different examples also. So windowing functions are lead, lag, first value, last value. For the clause, you can do count, sum, min, max, average, etc. Actually, in Oracle terminology, all these are considered as analytical functions only. There is no distinction between analytical functions, windowing functions, and over. The documentation is a little bit sloppy for Hive. In Oracle terminology, everything is analytical functions or analytics functions. In SQL Server and all, they use the term windowing functions for everything. But these guys have mixed up the things. Okay, so over clause is common whether you want to use windowing functions or analytics functions. Okay, with window you use this one between preceding and following, etc. Okay, so here using analytical functions or analytics functions, we can get count, sum, min, max, average, and also we can get row number, rank, dense rank, cumulative distribution, percentage rank, and entire. Okay, so I will. So for our purpose, the problem statement is to get the top 5 uh, uh, products by revenue. So I have to use either rank or dense rank. So the difference between rank and dense rank is if there are multiple. I will give you by example. So for rank, if you just want to get top 5 uh, products by revenue. So at times there can be duplicates. Even if you have duplicates, let's say by revenue, there are two records at the top. Okay, with rank, they will be given 1 and 2. Sometimes, sorry, I think they will be given the same rank, like 1 1 or 2 2. I do not remember exactly. Uh, let us try it out. So the major difference between rank and dense rank is in rank it will always give you 5 products only, irrespective of number of records that fall in that category of top 5 by revenue. It will only give 5 records all the time if you use rank. Whereas with dense rank, if there are 100 records which fall under the top 5 revenues for that day, it will return all those records. That's the difference between rank and dense rank. Okay, so we can use rank or dense rank for our purpose. It's better to use dense rank because there can be a scenario where the same where multiple products might generate the same amount of revenue on a given day. So theoretically, if I want to get top 5 products by revenue, I should use dense rank, not rank. Okay, if I use rank, if there are duplicates, still it will only give 5 records and it will skip the others. If you are sure that the data always give the unique values, then you should use rank. Performance-wise, rank is a bit better than dense rank. So in those scenarios where you are sure that you want to get only top 5, you will be getting only 5 unique records. If you ask for top 5, then you can directly use rank. Okay. So here I have to compute. I'm sorry. I have to compute. I have to get top 5 products by revenue. Okay, so how can I get the revenue? By actually aggregating the data. Uh, Here I'm going to Hive again. So I'm quitting from Scala because it is a bit convenient to write exploratory queries in Hive or Spark SQL. I'll be using Hive. Okay, it is very sorry. It is very important to follow now so that you don't have confusion. Uh, so yesterday we started with I think this simple query, right? No, not that one. We start with the one where we have group by. Let me see if I have here. Yeah, this is the one. Okay, I'm opening a new file here, and I'm deleting these things. Let me find and replace. Okay, and I don't want the having clause. So we started with this query, right, where we actually got the revenue by order date and product. Okay, if I use only, if I want to use group by to compute the rank, I can do that, but I will not be able to get the other details such as product description, product category ID, product price, whatever we want. Okay, for that purpose, even we have to manipulate this query to get the order item subtotal uh, for each order date and for each product. Uh, okay, and we don't need other information. We just need order date, product name, product category ID, and product price. So here you need to understand two things. You need to compare two things, and you need to decide whether to use analytical functions here to add product price and the product category ID, as long as it is one-to-one relationship between whatever we are aggregating on. So, for example, product name and product price is kind of one-to-one relationship. Okay. So what we can do, we can directly add product price here. And then because we are using group by, we have to add product price here also. Similarly, we can add product category ID. Product category ID have many to one relationship from category ID to product. As it has many to one relationship, we can include that also. But if we have one to many between the product name and some other column, where we in that case we cannot add to this here, and we might have to use analytical functions in those scenarios. So here I am also adding product category ID. Let me put it in multiple lines. Okay, and I need to add product category ID also in the group by clause. So this is one way of doing it. You can also use analytical functions the way we have done. So with analytical functions, we need to remove the group by clause, and we have and then we have to say over partition by order date comma p dot product name. But the if I try to do this, what will happen? You already seen the result. You will see the duplicates. For example, let me think about it. Yeah. So here, in this case, we got two records for this order ID, order date, product name, product category ID, product price, and order item subtotal and revenue. If you see, these are exact duplicates. These two. Okay. The reason is 1 minute. Let me. Okay, we should not. Yeah, I understand. So we have order date, product name, and we should not include order ID here. Okay, if we we don't need to get order ID for this purpose, so we don't need to include order ID. But what will happen is, if I run this query, let us do the count here. Okay, select count of 1 from queue, and also let me do count on this query also. So what I'm trying to say is, both these queries can result into the same thing, but this might get you duplicates unless you have additional column which will generate the uniqueness. In this case, it could be order ID. Unless you have that, it will you will feel that it is returning the duplicate values. Okay, the reason is, if I run this query, it is giving us around 158,000 records. But if we run this one, because it is already grouping by order date, product name, product price, product category ID, it gives only 9,000 odd records. Okay, as it gives duplicates, we cannot use as is like this. We have to add distinct to this. Distinct star from, and then you will get only the distinct records. Okay. Now we can use the results of this query or results of this query which are same to compute the ranking. So it's a multi-step process. First, we got the revenue for each order date, product name, along with the additional attributes like product price, product category ID, etc. Okay, up to this point, you can use either of the approach. But from here, you have to use the analytical function only. Okay, I will show you. See here, this query where I have used the analytics function to get the revenue along with order date, product name, product price, product category ID. It has written 150,816 records. But if we run this, there are only 9,000 combination of date and products. So this query will return only 9,000 records. We have seen yesterday also by running the count. Okay, now we can pick one of these queries and we have to add the functionality required to get the top 5 products. So if we use this one, again we have to nest this query so that we get order date, product name, or actually we can also say distinct here. Okay, and it also it will actually give us the 9,140 records. Once you get this one, okay, now I want to get O dot order date, this is required, P dot product name, this is required, P dot product price, this is required, and then P dot product category ID. I will answer that question, Bala. Just give me, let me finish this query. Okay. Once you get these 4 fields, now I want to compute the rank. How can I compute the rank? I have to use dense rank for this purpose. Okay, and then over partition by. In this case, it's only within the date. Within the date, I want to get the top 5 products by price. So I have to use partition by O dot order date. If I use partition by order date and product name, then it will give, it will try to compute top 5 within that, which is not correct. So here we have to just use partition by order date, and then I have to say order by, okay, revenue. Revenue is the derived field in this nested query. So I'm using order by revenue and then DESC. Okay, so it will actually compute the rank based upon the based upon each date by revenue in descending order. So this one will be rank. Okay, and we might not be able to use it in the where clause directly. So hence we have to nest this again. Okay, select star from. Let me nest it properly. Okay. Sorry. Okay, rank from. This is here, and then select. Okay, and then it is Q1. Okay, so this one will actually compute the rank, and then we are actually using these results, and we want to get only the records where rank is less than or equal to 5. Hence, we can use where R and K less than or equal to 5. Okay, and then you can run this query. There is some issue. Okay, there is some issue in this line. I think I should not use the apps. Apps seems to be causing some issue. Okay, let me run this query. Yeah, now it looks good. In this case, there is something, so distinct not allowed in the presence of windowing functions when CBO is off. So it is a kind of a warning. So what we can do is, so we have to nest again. So here I have to say, select distinct star from Q2. Okay, now let us run this query. Oh, I did not remove the distinct here. Yeah. Okay, in this case, it is given something else. Possible column names are order date, product price, product. Okay. Some incorrect references. I should not use these things here. That is the reason why. Because these aliases are for the inner query. So on the outer query, I don't need to specify these aliases. Yeah, that is not mandatory. As long as there are no conflicts with the column names, aliases are not mandatory. So now it is running. So while it is running, let me reiterate what we have done. What is our problem statement? Our problem statement is get top 5 products by price, sorry, by revenue within each day for completed and closed orders. So what I have done, first thing I have done is I have joined orders, order items, and products. Okay, because orders have the order status, as I have to get date and also check for completed and closed orders, I have to use orders. Order item subtotal, which is revenue, is in order items, and also the product ID is in order items. Without order items, I cannot go to the products directly. So I have to join order items for two things: one for order item subtotal, and the second one for the product ID. And as we need additional information of products, such as product name, product price, product category ID, etc., we have to join products also. So first thing, what I have done is I have joined these 3 tables. Okay, and then I applied the filter condition for order status in which are completed and closed orders. We don't need to specify order by here, so I can remove this thing. Okay, order by is not required. So once we are done with it, either once the join and filtering is done, either you can use the conventional group by to get the revenue by grouping by all these fields, such as order date, product name, product price, product category ID. Okay, or we can also use analytics functions like this. As analytics functions will not actually group the data by key, we have to use distinct on the top layer. Otherwise, you might result into duplicates. It is very important step to add distinct. Okay, if you go with analytics functions approach to by partitioning the data by keys and then aggregate or rank on top of it. Once that is done, this query will give me the revenue plus product details. Okay, or this query, both will give me the same thing. Once that is done, I have applied the distinct, and then I have actually, this is mandatory. You have to use analytics function only here. If you try to use non-analytics function approach, to get the top 5 records, you have to probably self-join the tables, the results 5 times or something. It's very complicated. It's at least 10 times complicated than this. Even performance-wise, because it results in multiple self-joins and all, it is it will perform poorly. Okay, that's why you should know analytics function, and you can implement very complex business cases with these powerful analytics functions. Okay, So here I want all the details which I am getting from inner query, such as order date, product name, product price, product category ID, etc. And then based on the order date and the revenue generated. So I also want revenue. Based on the order date and revenue generated, I want to compute the rank. Okay. Hence, after specifying all the fields in the select clause, I have used this analytics function called dense rank, and I want to rank within each date. That's why I partition by order date, and the criteria to generate the rank is revenue, and it has to be in descending order. That's why I mentioned order by revenue descending. And then I have given an alias to this column. If you want to get results in more readable format, you can actually say order by order date, comma, rank. Okay, that way you will get the results in a more appropriate fashion. Even now, it actually gave the results the way we are expecting. For each date, we can see the top 5 products by revenue. Earlier, I didn't include the revenue. That's why it was not showing revenue here. We will look at it using Spark. So I'm exiting from here. Now, if I want to do it using Spark Shell, I just have to put those codes. Or I think I can also do this. Yes. Okay. And let me try this. Probably this will work. Someone is asking for the query. I will give the query in a moment. Once I test it, I will definitely share it with you. I can. Okay, I cannot use. Okay, I'll close it. 1 minute. Let me see. Scala multi-line thing. Okay, let me try this. I will do that. Here I'm only creating the string. The editors are pain sometimes. We can run it in Spark SQL also, but I want to make sure that you understand the importance of Spark Shell against Spark SQL. For exploratory purposes, you can use Spark SQL, but to develop the programs, you should always fall back on. You should always fall back on Spark Shell. Okay. Now you can see the string. So now whatever you guys are mentioning, first I want to set the database .sql use wlabs bg, and also always make sure you understand your data behavior and set this important parameter to the manageable number. It will save a lot of time for you. Spark.sql.shuffle.functions. I want to use 2 of them. Sorry, Spark SQL.setConf. SQL context dot set off. Okay. Now I can use SQL context dot SQL, and I can pass the string literal, which is yes, and then I can run show. They have given the Q. Sorry, it is Q, not S. So you can also create string and then run the queries. So you can see the results. It is much faster. It starts with 2013 July 25th, and you can see the revenue here. Top 5 products by revenue for the uh, date of 25th July is uh, Field and Stream something, and Nightman's is the second one, Diamondback is the third one, Perfect Fitness is the fourth one, Pelican is the fifth one. Okay, so this is how you can actually uh, get the results. So I'm pasting this one. So let me val q equal to, and then SQL context dot SQL q dot show. So you can, I will give few minutes here. Um, you go through the query. If you have any questions, I will answer those. Otherwise, we'll move on to the file formats. Okay, and this is the URL which you need to focus on to understand this very important concept called uh, windowing and analytics functions. And try to be creative. You can use this orders data, retail DB data. You can also use uh, elections results, and you can create tables on top of it, and you can actually run these analytical queries. But these analytics functions, if you try to run in native SQL context, uh, in Spark, native Spark SQL context, it might not run as of 1.6. They are supposed to enhance as part of 2.x. So probably if you are using Spark 2.x, even if you try to run the queries in Spark native Spark SQL context, the analytical functions might work. But as of 1.6.2, if you just create case classes and create data frames and then register as temp tables, if you try to run analytics functions on top of them, it might not work as expected. Okay, so yeah, I will post these links in YouTube. Query you can post. You have to break into multiple lines, and you have to post the query. Okay. So is it clear? It's very, very important. I will tell you. I worked on a project for AT&T, and the queries were taking hours, and I fixed those queries just by using analytics functions, and I brought down to seconds, from couple of hours to seconds, and sometimes the queries even used to timeout. It's very, very powerful and very efficient. I think Oracle is the one who implemented it very effectively to begin with, but now most of the databases support these analytics functions, including Hive. But MySQL doesn't support analytics functions out of the box. Probably you might have to add some additional packages to get it working. But the typical MySQL does not support the analytics function, but all the other databases uh, support analytics functions. Yeah, so Spark SQL shuffle parameters. So if I do not set it, here I'm exiting, and I'll be launching again. Very good question, Srini. Srini is asking how can we execute this using IntelliJ? If it is a Spark SQL native context, you can actually take care of using IntelliJ. You can validate end to end. If you want to run it in the Hive context, you have to set up Hive local to your PC, and you have to integrate Hive with your Spark installation, and then only will be able to validate using IntelliJ. But development perspective, you can do, but you will not be able to validate using IntelliJ unless you have Hive, and that Hive is integrated with your Spark. Okay. Only validation part will be missing. Otherwise, everything else uh, can be implemented the same way we have been doing so far. So let me show you that. So meanwhile, I will answer Piyush's question about Spark SQL shuffle parameter. By default, if you see the value of Spark SQL dot shuffle dot partitions, it is 200. So if your job requires shuffling, it will try to use 200 tasks for each stage wherever shuffling is required. And this 200 might not be the correct value. For example, if you are joining 5 different tables, and if few of the tables are smaller tables and few of the tables are bigger tables, you might have to break down that query and you have to play with this parameter to use resources more appropriately, to reduce the number of tasks to process the smaller sets of data. Okay, for example, uh, if I run select order status from orders group by order status. I guess this requires shuffling. So if you see, the query is running with 200 tasks and it took almost 1.471 seconds. But our data size is very small. So we don't need to use this much horsepower to process our small data set. So now I'm changing it to 2. Now if I run the query, it just took sub-seconds because it only used 2 tasks to process the data. Okay, so that is about Spark SQL shuffle partitions. So Bala is saying if we need to run the same query in Spark native context, we should create the case class, and then that's correct. Can you please revise once when to use RDDDF, Spark native context, Spark HiveContext, and yeah. So I will be covering that. But first, I need to focus on a bit more important topic called file formats. And then, if time permits, I will cover this, or we can actually catch up as part of the next session, which I will be scheduling for Saturday or Sunday. I will definitely answer this question because we are a bit behind, and I have to close the session by 10:05 or 10:10 today because I have some engagement at 10:30. Hence, I might not be able to answer this question, but definitely I will cover it when we catch up next time. Okay. So that being said, let's get into the a very important topic, file formats. Okay, if you go to the material in the data frames and Spark SQL itself, there is a topic on different file formats. And these are the file formats which are supported out of the box with Hive, with Scoop, with Spark. Okay. For now, I will be primarily focusing on how we can deal with these things using Spark. Okay. So first, let us understand the difference between these file formats. Text file is we are already seeing this, and you all understand text file. The next one is JSON file. So JSON means JavaScript object notation. Okay, and you can actually store the data uh, in the form of JavaScript objects. And how the JavaScript objects look like? So it will typically look like. Let me take an example. it will typically look like this. Okay, it is similar to XML, but the major difference between XML and JSON is with XML you have a opening tag and closing tag. So the size of XML is pretty big because for each and every value, for each and every branch, for each and every root, you have to have opening tag and closing tag. Whereas here, there is no opening tag and closing tag. There is only name, okay, and then the value for it. So the size of JSON is relatively much smaller and compact compared to XML, which means it gives a lot of performance boost when we actually exchange this information over the network and all compared to XML. So that's why JSON is getting quite popular. But if you are familiar with XML, you will be able to understand JSON also very quickly. It is fast, compact, and cross-platform, and it is the I think most popular file format or data structure as of today than XML itself. And there are other formats also like YML and all those things. These are all similar. The philosophy behind these file formats are same, but the way they represent it is a bit different. With XML, you have closing and opening tags. With the JSON format, you have name and value pairs. So instead of text files, you might have JSON data as part of your file, and you can create files in JSON format itself. And if you have that, our Spark APIs provide a way to read and write the JSON data. We will see that in action in a moment. So that is the difference between text file and JSON file. JSON file is also mostly in text format, but it also have the metadata for each and every value. Just give a moment. And then the other file formats, sequence file, Parquet file, ORC file, and Navro file. So sequence file is a binary format. Unlike text file and JSON, you will not be able to see the data by opening the file. You have to only open it programmatically, and you have to process it programmatically. Okay, and it also stores metadata along with the data internally in the binary format. And sequence file is specific to HDFS. If you want to process it, you have to use HDFS API first to write it in the sequence file, and then you can read it as a sequence file and you can process it. Okay, it's in one line you can say that sequence file is nothing but binary file format. Then comes Parquet file and ORC file. So if you are familiar with data warehousing, there is something called columnar file format. Columnar file format. Okay, what does that mean? So if you think about it, I'm sorry, I have stuffed nose and it's blocking me speaking today. Okay, if you are familiar with data warehousing, you have fact tables, and in those fact tables you have measures, and from that we will compute metrics. Okay, what is measure? It's a discrete value. For example, a gender can be a measure on which we want to compute a metric. Gender typically have male and female. It will not have any other value. Typically, if you want to consider date as measure, then, and if you want to compute metrics, and if you want to perform something monthly, for a given year, there will be only 12 distinct values. If your data set is 10 years worth of data, then that field will have 120 unique values. No matter the size of the table, the unique number of the months will be only 120. Okay, if so, and in fact tables will be typically thin. You will not have hundreds of columns in them. You will have some business fields such as product category ID, etc. Those are called as dimensions. And then you have these metrics, measures or metrics. Okay, so if I want to if I want to get metrics based on gender or based on month, typically the data is stored at the data in Oracle or many traditional databases will be stored row level. So, for example, if you are if you go to the internals about the file format, a file is nothing but contiguous blocks, and each block will contain a series of rows. If you think about traditional table, okay, if you store it as a series of rows, if I want to compute some metric on a monthly basis, whether I require or not, I have to read the other fields also. Okay, not only those fields which are required for my report. When we actually query, even though we select only those fields that are required for us, still as part of the IO will be done at block level. So it will actually read the entire row into the memory and then it will process. So for example, if you have 10 GB worth of data, and if you try to run a metric on top of it, no matter you select only few fields, still 10 GB worth of data has to be copied to memory, and then only the processing happens, which can be very inefficient when you try to do the batch processing. It works very well for Oracle for transactional based systems, but when it comes to batch processing, it might not work very well because we are trying to read the entire 10 GB of data and then we are trying to process. So to avoid that problem in the data warehousing world, companies like Greenplum, Vertica, etc., they introduced a concept called columnar storage. Instead of storing in the rows, they actually store the data in columns. So you have to create your tables in a specific manner if you want to leverage this columnar effectively. All the related fields has to be uh, uh, should be living together, um, so that related data for those related fields go into the same block, avoiding the IO, and the performance can be fast. For example, if I create a table with three fields with gender as one of them, if gender goes to one set of files, I can ignore the other two set of files while processing the data. When I say it's not me, but the underlying database engine can discard the other other files which store the other information. It can only go through the column which we are interested in and go to the files of that column, and it can actually get the results. And the main advantage is compression rate. So if you think about it, if we have only gender data, male and female, you can get 1000x compression if you actually store the information in the columnar format. Similarly, if it is date or month, even then it can get a very high degree of compression. Because of the higher degree of compression, your storage requirements can go down significantly. On top of it, your performance also can be much faster. Your amount of IO will go down significantly, and as the data is staying closely together, downstream processing also much faster. So that's where the concept of columnar file formats come in. And the answer for columnar file formats within Hadoop ecosystem or big data ecosystem are ORC file and Parquet file. Okay, ORC file is primarily developed by Cloudera, Hortonworks folks. Parquet is actually developed by, I think, Facebook. Okay, both the philosophy behind these two file formats is same. It's primarily for columnar format, which will give us better storage when it comes to storing the fact tables for data housing kind of requirements. It will give us better compression rate. Even the performance of our queries are good, will be good as long as we use these things effectively. And then finally, Avro file. Avro is nothing but binary JSON format. Okay, so these are the file formats, and now we will see how to actually use these things as part of the program. Okay, so if you see here, text file and sequence file, we have to use the Spark context object for this. So now I am in the Spark shell. SC is the Spark context, and SC dot, if you hit tab, we have the options of object file, sequence file, and text file. Okay, object file is a bit different. We don't use that often. It is primarily to store serialized objects, um, uh, or to read the serialized objects. So if you store the serialized objects into the file system, and if you want to read those things, you can use the object file, which is native to Scala. Only Scala supports that. Python does not support. So object file is not very important. Text file and sequence file are the ones which can be used using Spark context to read data from text files or sequence files. Rest of the file formats, we have to use SQL context. No, Piyush, it doesn't mean that Parkway file would have just one column. So let's say you have 10 fields in a table, and it will internally decide. You don't specify what which 3 columns should be stored in one set of files, and how the other fields should be stored. Only thing you need to take care is you have to group all the relevant fields for a particular report or for a particular requirement together while creating the table. Then internally it will actually create the files in such a way that it, depending upon the nature of the data, it will make certain assumptions, and probably 3 columns might go into one set of files, and 4 other columns might go into other set of files, and 3 other columns might go into other set of files. And there will be some pointers which will be used to communicate between them. You don't need to worry too much about it. You just have to make sure that while creating the table, the related columns should be defined close to each other. So sometimes it might read only one set of files. Sometimes it might have to read a couple of set of files. It is not that it will create one file for one column. It's not that. It will be if you define a table as a Parkway file or ORC file format, or what will happen is, depending upon the set of columns which are close to each other, it will decide to keep the data. Okay, so that's about even ORC file also. Is it clear, or do you still have the question? Okay. So now SC can be used to read data from text file and sequence file. If you have to read the data from sequence file, you have to tell the key and value type. So because with the text file, let me demonstrate here. I'm reading the text data from public detail underscore DB orders. It have the text data. Okay, and then take off 10 for each println. As it is text data, when you use text file, it understands that each record, each line is a record. Okay, so whatever is the number of lines you have in that file, RDD will be created based on those things. So it can make that assumption, and we'll get accurate results when you actually use sc.text file to read the text data. And the text data means it should have only the alphanumeric characters, no special characters in that. If you have special characters, then it might behave a little bit weird. Okay, but when it comes to sequence file, it is binary format, and you need to define what is key and what is value, so that it stores the metadata internally, so that when we try to read it back, it uses that metadata to actually get the information. So what I will do is, in this case, I will read data from orders, and I will first save as sequence file. so that you understand how the data will be stored. So the first parameter for save as sequence file is the path to which you want to write the data to. Okay. So here the path is /user/dgajraju orders sequence. Okay, and then we have to tell what is the data type of the key and what is the data type of the value. Okay, and also to use sequence file, first I need to segregate the key and values. I need to identify what is the key and what is the value. For that purpose, I have to use the map function here. Otherwise, we cannot tell what is key and what is value, because our RDD is just a plain text, and each element in RDD is nothing but string. Okay, so here I have to say text.split queen, and then I want to save the value, rest of the stuff as the value. Okay, here to get the rest of the stuff. For now, I will just keep it as rec. Okay, so the key will be the first field, and the value is entire record in this case. Typically, we have to discard the first field and store the rest of the stuff. Uh, uh, but for simplicity's sake, I am actually considering the record itself as value. Okay, it got disconnected. While it is launching, let me answer these questions. That you don't need to worry too much about it. It will actually maintain the metadata. Whatever you are saying as key, it will store internally, and whatever you are saying it as value, it will maintain the metadata internally. You will see the garbled information, and you don't need to break your head on top of about it, unless you want to be um, a file system developer. You don't need to worry about those things, how the metadata is stored. Okay, so but to have that metadata, to tell what is key and what is value, we have to use the map function, and we have to specify what is the data type of the key and what is the data type of the value, so that it can store that information internally. So I'm starting here again. Nothing. There are two different vendors trying to solve the same problem. Earlier, they used to have RC file. RC file have many issues. Performance-wise and compression-wise, it is not very flexible. Hence, Facebook guys have developed the Parquet format, but all those issues are resolved in ORC file format. And as for my knowledge goes, you don't find much of a difference between ORC and Parquet. Okay, now it is launched. Okay, so let me create multiple variables here. Val orders equal to and then map right implies dot split 0 and then rec. And then I can say orders dot save as sequence file. Okay, first I have to give the path, which is user Raju orders sequence, and then I have to tell what is the type of the key and value. And when you specify this, you have to give the Hadoop HDFS related key and value types. Okay, so I don't want to get into too much details here, but I will give a brief overview about it. So arg.apache.hadoop io dot int writable is key because we are converting our okay, I haven't converted into integer, but I will do that. Okay, so let me copy this one. I will explain what is this int writable in a moment. Here I want to set to int and then paste here. And then I also want to specify the data type of the value. Okay, path codec. 1 minute. Let me see the syntax here. Class of. Okay, just give me a moment. I should have this. I should have it. I will add the examples also to that blog. Okay. Yeah. So while writing, we don't need to specify key and value type. That's okay. I understand the problem. So while writing, we don't need to specify this key and value type because we have already defined as part of the RDD itself. This orders is of type intent text. Once we create the RDD, it is of type each element is of type intent string. Using that information, it internally uses the appropriate data types which are related to HDFS. Now, if I go to that path on a different session, and if I say Hadoop FS -ls user Raju orders underscore sequence, you can see the files here, and you can say Hadoop FS -cat. Okay. Yeah, part -5 5 zeros and more. You see here internally it uses the solve.apache.hadoop.io.intwritable for key and this one for value. So this is the metadata which it will store internally. Using this information, you can actually read the data later. So for example, if I want to read it from sequence file now, I have to say sc.sequence file, and I can do the path user Raju orders underscore sequence, and then I have to specify the class for both key as well as value. So let me show you the example here. So this is how you should specify. Okay, so I already have it here. You can also import and only use the class name instead of specifying out.apache.hadoop.io or in both the cases. Whatever is convenient to you. Okay, and you can also say dot takeoff 10 dot reach println. There is some issue here. Object not. Okay, here I think I have to use map. Yeah, because it is reading from binary format. It is causing the issue. Now you can see the results. Okay, so this is how you can actually read it. So I will add this example also to that blog so that you don't need to struggle with this. But this is how you can save it as sequence file and you can read from sequence file. If you want to use compression, you can add compression codec as additional parameter while saying save as text file. While reading, quite often you don't need to specify the compression codec. It will, as long as they are supported, it will automatically read based upon the underlying file format. Okay, but while writing, you have to specify the compression codec. And the way you use compression codec is one of the shortcut is to go to etc hadoop conf and go to coresite.xml file. Okay, and then you search for codec. These are the supported compression codecs as of today in our cluster: gzip codec, default codec, and snappy codec. And you have to give this a complete class name while compressing the data. And it is applicable for each and every file format. Whenever you want to compress, wherever the syntax says uh, uh, use a particular compression format, you have to tell that compression as per the syntax requirement. Okay, and now let us see how we can actually read JSON data. Let me see if I have JSON on in my directories. We find actually what we can do is we can write the data as JSON. We already have this orders. Let me create the orders RDD and let me try to create JSON out of this. Okay. Uh, so to write it into JSON, you have to convert your data into data frame. Unless you convert data into your data frame, you will not be able to write it as JSON, because if you have to create a JSON, it has to have the name and value case for everything. So for that purpose, what we have to do is we have to create a case class here for orders, case class orders, and we have order ID here, order date, string, order customer ID, integer, and order status. This is our case class orders. Okay. Now what I have to do? I have to first convert our data into data frame. What I need to do? Orders dot map. Okay, and then val a equal to rect dot split, which will result in an array. I hope you guys are following this. And then I want to create a data frame for orders. So first one is a of 0 dot to int, a of 1, and a of 2 dot to int, then a of 3. Okay, so this will actually create RDD of type orders, and I want to convert into data frame, so I can use 2df here. Okay, I got it. The problem is I use the same name for RDD as well as the class, which is overriding. So I have to change the name of the case class. Okay, and then I have to implement this logic. So now data frame is created. Let me create a variable for this. Val orders df equal to paste it. Okay, now orders df is a data frame, which means we have defined the structure on top of the data. Now we can use this orders df and then use dot, and then we can use two JSON function. Okay, and then we can say save as. So if I say two JSON, it will just create a RDD of. So from RDD we have created a data frame so that we get the metadata. Once we got the metadata, again we are converting to RDD and we are saving as text file. That is one way we can write it into JSON format. Okay, so I can say orders df.toJSON dot save as text file, and I can give the path, and then data will be stored in JSON format. There is another way of doing it. We can also say orders df dot write, okay, and then dot, we can use JSON here, okay, and then we can do the path. Let me see the syntax. We can do the path. So here I am using user dgaduraju orders underscore JSON, hit enter. I think it is already existing. Yeah. So let me create one more file, JSON1, and hit enter. Now the data is saved. I'm going to end the session. I hope you guys followed it. I'm going a bit faster because of the time constraint. So what I have done is I created a case class orders, read the data as RDD, and converted that into data frame after applying the case class here. And then either we can convert into JSON based RDD by using two JSON on the data frame, or there is a common API called write. And if you look at it, orders df dot write, it supports several formats. It supports JSON, it supports JDBC. You can connect to the database and write into JDBC. It supports ORC, it supports Parquet, all these things. Okay, so it is very important to understand this write and read. Read is on top of a SQL context. Once we actually have the data in JSON format, we can read data from JSON directly using read on SQL context, and we can process further. Okay, that being said, let me go here and show you Hadoop FS -ls user dgaduraju orders JSON1 and hit enter to see the file here. And then you can actually say Hadoop FS cat more. You can see the data. It is in the JSON format, and for each and every record, the column names are also repeated. RDD cannot be directly converted to DF. You have to have the structure to have the data frame. Data frame is nothing but a structured RDD, structured distributed collection. Probably using a single column you might be able to create, but that is not the appropriate way. Okay, you need to have structure if you want to use data frame. That is the major difference. Okay, now to read it, always remember one thing: reading happens on the context. If it is text file or sequence file, it is Spark context. For other formats, it is SQL context. So here I can say SQL context dot read dot, and you can see it can read from JSON, ORC, Parquet, etc. So in this case, I want to read from JSON, and user dgaduraju orders underscore JSON1, and then let us see what it will return. It returns a data frame. As it returns data frame, I can use show to see the results, and you can see the data. Okay. So there is a question here. DF is kind of, yes, it's nothing but structure on top of a distributed collection. You should think it as a distributed collection. RDD is a unstructured distributed collection. DF is a structured distributed collection. And they are trying to, as part of Spark 2, as I understand, they want to use a common term called dataset for everything. And it's more dataset driven than data frame or RDD to avoid this confusion. Okay. So now we understand how to read and write from JSON also. Very straightforward, as long as you understand this read and write. Okay. So for except for arrow, you can see read and write are available either on SQL context. Read and write are available for different file formats, either on SQL context or on the data frame. So orders df dot write, and you can see options here. Okay, so Parquet and ORC is almost same as JSON. With Avro, we have to integrate a third-party dependency for it. Let me see if I already have it. It is not there. So what we have to do is, while launching itself, there is something called packages. Okay, and sorry. Yeah. So this is what you need to use. So here you can see I am trying to import a package called com.databricks Spark Avro 2.10 uh, uh, compiled with 2.10 version of Scala, and this is the Spark Avro version. So it will actually download the packages and register, and it will launch the session. If you go for Cloudera certification, you don't need to worry too much about it. That will be provided to you, or they will give the enough information. You just need to understand there is a approach where you can use hyphen packages, and this is the artifact ID, and this is the group ID, and this is the version. Okay, if you are familiar with pom.xml and our library dependencies, uh, so this is pom.databricks. This is spark-avro underscore 2.10, and here it is 2.1. Blah 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 2.0.1. So as long as you can interpret this information and you can register on the fly, that is good enough. You don't need to worry too much about it. They will provide enough information to you. Okay, so we can launch Spark Shell like this, and you can see it actually downloaded this additional dependency. Also, if you are using IntelliJ, you can define the library dependency as part of this. And even while running the program, we can actually specify using jars. So library dependencies plus equal to pom.databricks percentage spark avro underscore 2.10 percentage 2.0.1. Then you will be able to use as part of your IntelliJ also. So keeping these dependencies in mind is very, very important. So now it is launched. Now let me try importing it and see if it works. Now it works. But still, if you say SQL context dot read dot tab, it might not show Avro here. This is the autofill is not 100% foolproof. So even if there is no Avro format here, you can use the Avro format without any issues. So first, let me write the data in Avro format. For that, again, I have to go through creating the case class, then create the RDD, Okay. Actually, I can use history. Yeah. Now I can actually copy this part. Okay. Now I can say orders df dot right dot uh, have row. Okay. Give the path user d Raju orders underscore have row. Hit enter. Again, it might already exist. Yes, it already exists. So I am giving it as one. Now the data is written in arrow format, and we can go here. You can see the data here with arrow extension. And when it comes to compression, you need to try different compressions. So with Snappy will work with almost everything except for ORC, I guess. ORC works with only default and gzip. There are some issues, compatibility issues with compression algorithms of different file formats. So I will highly recommend to try Snappy gzip, the default one on all these things, and see the results, how it is actually, whether it is working or not first, and if it is working, how much compression it is creating and all. So instead of using the smaller data sets, you should try it with a bigger data set. For example, in this case, uh, probably the word count program, whatever I have as part of the random text writer, you might want to compress you might want to save it in ORC file format and compress, or you might have to come up with bigger data sets representing structures. Without structure, for random text writer, it might not be a decent use case. But if you have good size data set with at least few hundreds of thousands of records, if not millions, you will feel the difference between using different file formats and different compression algorithms. But at least functionally, you should have the knowledge. Even if you didn't get a chance to into internals, functionally, you need to make sure that you are comfortable in using these different file formats and different compression algorithms. Okay. So that being said, I can take a couple of questions here. I have to put the hard stop by 10:05. So I will answer as many questions as you have. And as I have mentioned to you earlier, I will send an Amazon Chime invite for all these guys. And also I will stream that on YouTube also. I will share the details with you for sure. It will be either Saturday or Sunday, and you can come up with any questions you have with respect to big data for that session. It will be 1 hour to 1.5 hour session. So file formats is very important for certifications, especially CCA. Almost every question they are asking about file formats, and you should know how to use the delimiters effectively. What type of file format they have asked, you have to respond accordingly, and also you should be comfortable with compressions. If you are comfortable with these three things, rest of the stuff is very straightforward. Yes, Piyush, but I have a couple of good videos on that. Uh, Let me share the details with you. It will take at least 3 hours to cover Flume, Kafka, um, sorry, and Spark streaming. So what I will recommend is go to CCS Spark and Hadoop Developer playlist, and here you see 15, 16, and 17. Flume, Kafka, and Spark streaming. Actually, it takes more than 3 hours. Okay, go through these videos, and if you have any questions, raise it on discuss.itversity.com, and I will be glad to answer those questions. And this only covers Kafka as plugin. I haven't covered how to extend Kafka by writing additional functionality or enhancing the core capabilities of Kafka. Probably in future, I will create a course on Kafka alone. Kafka is getting very popular these days. It is not only used in big data projects, but even in regular projects, Kafka is being used quite extensively. Yeah, as of today, simulator is available. Only thing is questions are missing. So I would recommend you to go and start using the simulator, get used to the terminal and all those things. And if you have any questions, you can write those things. I will definitely create questions by mid of next week, and we'll at least have more than a month to actually practice because I am giving it to you till September 30th. And as and when you see the issues, let us know immediately. We will try to fix all the issues on BW02 as a higher priority because we want to roll out a new product in October by providing the certification simulator for multiple things. So Somalia is asking, can we save those top 4 results into an Excel sheet? Excel is a file format which is not supported out of the box in Spark or HDFS. So the answer is no, you cannot save it into an Excel sheet. You can save it into a CSV file format. And from there, you have to copy into your PC and you open with your Excel. That is one approach. And another approach is there are some visualization tools which will convert that data into PDF or Excel. You have to use those visualization tools which can connect to the HDFS through Spark driver, Spark SQL driver, and you can get the results using the visualization tools. So CSV, yeah. So it is pretty straightforward. If you, there are multiple ways to do that. You can create a table with delimiter with comma as delimiter, and you can save the results into the table which is in Hive, and your data will be in CSV format. And the other way is, let me, very good question actually. So this is the query, and also let me first set context.sql use wlabs dg context dot set conf sql dot sorry arc dot sql dot tuple dot partitions two. Okay, now I can actually run this and it will return a data frame for me. Okay, as part of the write, let me save this val results equal to res is of type data frame, and then res dot write dot. So there is no CSV directly here, but if you actually use Databricks APIs, you can actually write into CSV directly also. But even without that, what you can do is you can convert into a RDD by saying res.rdd and hit enter. And it returns something called row. Okay. And then you can actually apply map rec implies rec of 0. Let me try this. Yeah. Rec of 0. Then plus comma plus rec of 1. Now the data will be in the comma separated manner, 100 for each println and hit enter. Now you see I only got two two fields, but if you want, you can add others also. There is another easier way. Okay, here what you can do is you can actually say rec dot. I forgot the MK string or something. Yeah, this is how you can convert the results. Now you can see all the values comma separated. So the row have this functionality called make string. It comes with most of the collection, so you can use that to convert your arrays into comma separated strings, and that's what we are doing. Rec is nothing but a collection in this case. So let me show you here. I have to stop after this. This is of type data frame. This is of type RDD. Data frame, when we actually apply RDD, it will actually create RDD of type row. Row is itself is a collection of several columns. It's kind of a tuple. And in this tuple, we have 5 fields. Okay, and on a tuple, so if I have tuple t equal to 1 comma hello world. Even t dot, this tuple also have this next. Okay, this doesn't have. I think row is a bit special. The row data type have this make string function, and that's what I have used here as part of the map to convert this row into a comma separated string using this function. And then I previewed using take of 100. If you want, you can say save as text file, and it will be saved as CSV. Is that clear, Somalia? Okay. That being said, I need to stop here. Thank you very much for joining the session and for the whole course. And thank you very much for being patient with the technical issues we have. I will try to address those things in future. I was expecting it was due to the laptop or the network connectivity on my side. If I have realized that it was WebEx issue, I would have addressed it much before. Uh, uh, anyway, thank you very much for being patient. And I'll be making announcements whenever we have courses. We have hired a new BDM also, and we will try to formalize quite a bit. We'll bring structure to the content also, so that it is uh, not complex for you to navigate through the content. Uh, and uh, and yeah, I will be conducting uh, one-off workshops, and I will be sending invitations to those. If you are interested, you can join. And also soon I will be creating a website for to getting the feedback, and I will share those that also with you. And feel free to give the constructive feedback. Okay, if there are any gaps, please let me know. I will try to address those things as part of the future sessions. That being said, thank you. Bye. Those who are on YouTube, thank you very much for joining the session. As I have been mentioning, if you like the content, please click on the like button. And if you want to provide the feedback once the streaming is done, you can post it in the comments. You can share with your friends by clicking on share on Twitter, Facebook, Google Plus, etc. And finally, if you need environment to practice, you can go to labs.itversity.com. Sorry, I typed incorrect. Labs.itversity.com is the environment to practice, and then discuss.itversity.com is the forums. And my GitHub account is it's a bit scattered now, so but you can actually check for this one. For my gist code snippets, you have to go to here gist.github.com/. Okay, thank you very much. Bye.